now we have our content parts and content type defined, but we don't really have an editor or a display for our content part. So the next step is to, well, create something for that. And what we'll do is that, well, first of all, we write shape templates, same kind of shape templates as we have done during the theme development part. And also we'll create drivers. Now, what are drivers, or why do we have all of these concepts here? Remember that still the principle of Orchard, or one of the guiding principles of Orchard, is that it should be flexible. The content model should be flexible and extensible. And that means that when you are building a content item, it should be possible to swap out pieces of it. It should be possible to put together a content item, or rather the underlying content type, out of little building blocks. And of course, those are content parts and those are content fields. And that also means that all of these little building blocks should be somehow self-contained. If you have a title part that deals with the title of a content item, you should be able to put that title part onto the content item and not do anything else, not have to configure anything, not have to write codes to do some plumbing. You should be able to just tell Orchard that I want title part on this content type, and that's it. So that means that the content parts should deal with their own display, with their own editor, or whatever they need. Pretty much you should be able to put a content part into its own separate module, and it should be self-contained in that separate module as such. And that's actually the case with, for example, title part. It's in its own module. And because of this self-contained nature, because of this encapsulation, we have drivers. We tend to say that drivers are kind of like controllers for content parts. They basically orchestrate everything that's necessary to display the editor or the display of that content part. They create view models, they prepare data for the editor and handle the postback of that editor. Those basic things. So what we'll do now is that we'll create a driver for our content part to prepare everything for its editor and display. We'll also create the corresponding view templates, or specifically content part shape templates, and we'll also create corresponding view models. So let's see. Let's go back to our solution, and I will put the startup file pinned up here because we'll need it multiple times. And let's start from our person part. This is the part that we'll create the driver for. So let's go into the module and let's add another namespace, drivers. We commonly put drivers into the drivers namespace / folder. And how we commonly name drivers is first it's the content part name and then display driver. Because specifically drivers, saying driver is just a short form, properly this is called a display driver. And we could write a lot of code here, but instead I will use, can you guess it? A snippet. That's right. We again have smaller snippets here, like with migrations, and a bigger one called OC part driver full. The OC part driver snippet would just create a basic skeleton of a driver, nothing in it, just all the basics. But OC part driver full creates pretty much everything you need in every content parts driver. Of course, your mileage may vary, and this is just the very basics, and this is just one scenario, but it's a very frequent scenario, so why not write the whole thing with tab. And now we have to fill out everything. First, we'll need to specify the name of the part, and pretty much that's it. Once I hit enter here, everything else will be pre-filled. And there's a lot of stuff here, so we'll need to take a bit of time to understand it. First of all, a driver needs to derive from content part display driver, and you might have guessed it that we also need to register it in the startup class. So it's a good practice to actually start with there, hence startup, you get it, because then you won't forget it. Because if you forget it, you will have a hard time scratching your head figuring out why is this not working. Oh, of course, I forgot it in the startup class. But we can, oops, not here, we can quickly add this registration, and actually how you add that registration is by chaining a method onto add content parts, specifically this use display driver, or rather this one, and we are using person part display driver, and now we have the driver registration ready. So let's get back to the driver and let's fix it. What we have here as this scaffolding is the following. We have a display and an edit method. The display method will prepare everything for the content parts display, mostly on the front end. Not necessarily. This can also work behind the scenes when you are displaying a content item with this content part on the admin in a list, so the summary admin display type, as we have seen before, or as we have discussed before. But this is definitely used most frequently when it's displayed on the front end, when it's displayed in detail display type on the front end, or in summary display type in a list on the front end. And the editor is, well, preparing everything for the editor when you display, when you open that editor on the admin area. And furthermore, we also have an update async method. This update async method will handle the postback when the editor is submitted. Because remember that we are now in a building block. This content part will be parts of the currently edited content item, but it won't be the whole content item. There can be other parts that contribute to the same editor. They will have their own fragment of the form there. And in the end, all of these will come from all of the content parts editors or drivers editors. And although we won't look into fields, fields are very, very similar. And finally, we have this little helper method, populate view model here, which is, well, about populating the view model from the data of the content part. Because, as said, we'll also have a view model. So let's actually create that, because we still have a build error here, because we don't have a person part view model. So let's create a view model here. We commonly put view models into the view models namespace. So let's create our view model class there. And you know, view models are just view models as everywhere in MVC. So I won't explain the concept too much. Just do know that a view model is an object that transfers data from your storage models or backend models, like the person part, onto your views. So in your views, you don't necessarily need to or want to access all the data of your content part in this case, for example. And secondly, in your views, you might need your data from your content part in a bit different way. So commonly in the driver, we don't just copy everything over to the view model, but we also pre-process the data a bit. This is a very simple case, so that won't be necessary, but do note that that is one thing we commonly do as well. And well, the view model in this case can be very similar to our content part. We'll need all of our own custom properties. We won't need the shortcuts to the text field, because that's the field has its own view model and everything. We don't need to care about that. Yeah, we can make the class public. It could be internal, but well, maybe for extensibility that's sometimes good. We'll also need handedness here. So pretty much the same things. One thing though, this is now a view model. This will be updated from the post data that the user submits. So we'll also need to do some validation here. And you can do some validation in the driver too when you are handling the post. But there are also data validation attributes, so it's just simple to use them. Because for example, a person surely has to have a name. So let's make this property required. And we can also say that we actually require handedness too, and we require the birth date as well. And of course, we could do further validation on a birth date. Like we could say that, well, the person should be 18 years old or older. And secondly, we say that they can't be older than, I don't know, 115 years old or whatever the oldest person is. But we'll keep things simpler here because the validating view models is the same as validating view models anywhere. Not much Orchard specific. You don't need to know about Orchard, or you don't need the Dojo course to learn about view model validation. So we have our view model prepared here. The next step is to actually import the namespace. So now we have that builder organ. And let's also implement this populate view model method here. This needs to contain well all the data preparation between the content part and the view model. So pretty much we'll need to assign all the properties. Assign all the properties of the view model. So it can be birth dates, comes from the birth dates. We'll need the handedness, which comes from the handedness, of course, and we will need the name as well, coming from the name property here. All right, now we have this here. The next step is to actually make the driver work. And we don't really need much here because the snippet prepares almost everything for us. And we don't really need to change anything on the display because that's pretty much ready. But what's in here, just let's quickly glance through it so you can understand. The display will create the shape for when the content part is displayed on the front end, either in details or when a content item is opened, or in summary when the content item is listed, or potentially also on the admin when the content item is listed in the summary admin. But we are actually not caring about those here. We just care about detail and summary. And what happens here is that we have this initialize helper here to create a shape which will receive this view model. The first parameter of this initialize is the shape type. Remember that the shape type is that identifier that the shape has, which is used when displaying it, and which is also used when binding the shape to a shape template, to a CSHTML file or liquid file. And this shape type is actually generated with this getDisplayShapeType method. And by default, the display shape type for a content part will have the same name as the content part. That will be person part. And let's actually create that shape template now. And before that, just a few notes on the remaining three lines here. We also pass a view model, or rather we have a view model factory here. you see that it creates the view model. That's it. It is called initialize here in the parameter list. Having such a factory method for the view model is also important. That means that your view model will be only created if the shape is actually displayed. Because remember that we can hide shapes also from placement. And in this case, this doesn't really matter because producing the view model is pretty much trivial. But if you are fetching some kind of external data from an external API, or you are producing some data which is expensive to create, like a lot of computations go to it, several hundred milliseconds are taken to produce that data, then it's best to actually only fetch that if it's indeed needed. But if you hide the shape, you don't want to produce the view model's data. And that's why we have this factory. This factory won't be executed if the shape is hidden. That's it. Long story short, use a factory. But that's what the snippet generates anyway. And finally, we have these two location declarations here, and this is placement. The same placement that we have seen from placement.json, just this is from code. This is a bit of a shortcut because we are already targeting the content parts shape, of course. And so we don't have to specify that, unlike in placement. And here we are targeting the detail display type, and here the summary. And for both of these, we specify the placement of content 5. So the shape will be put into the content local zone with a weight or an ordering value of 5. So that's good. Let's also create the corresponding shape template. And as I said, the shape template is in this case will be called just person part, and it's a shape template, so it goes into the views folder. Yeah, it's logical. It's a template, so it goes in the views. Yeah, you get it. So let's create a file here, and let's call it person part. .cshtml. And I will now cheat a bit, so you don't have to watch me type this in. It's not that interesting. What we have here is, well, a very simple display you see for the content parts details. And as the model, we are using the person part view model. There is a bit of a pickle here, and the bit of a pickle is that, again, we have build errors in the template. And the reason is the same why we had build errors in our theme templates. We need such a view imports file. So I will actually copy this. And it will be almost good. Now localization is working. The view model is not yet working. So we have two options. Either I could specify the whole namespace here, or I could add the namespace to here into the view imports as well. I will just specify it here because well, we won't really need the namespace of the view model or the view models in every view. Let's just specify the full namespace here. So we'll need Dojo Course module view models and then person part view model. All right. Now this is done. Let's go back to the driver and let's finish up with the editor, and then we'll be able to run the whole thing and see how it works. We have an edit method here, which is very similar to the display method. Of course, the difference being that this will produce the editor shape template or editor shape, and then a corresponding shape template will be found too. We are using the same view model here. Usually that's enough. Commonly, that's the case that there is a separate view model for the display and a separate view model for the editor. We will keep things simpler here. We don't really need anything else, but feel free to mix and match here. The editor produces the shape, or rather first the display result in pretty much the same way as the display. We also have such a method that will produce the shape type. Actually, the name of the shape that will produce here will be person part underscore edit. So we also name the shape template similarly. It will be person part dot edit .cshtml. We also have a factory method here for the view model. Same thing. And we also have a localization declaration which works in the same way. But we also need to care about update async here. That's pretty important because with the edit we'll display a form, a fragment of the form, but when we submit that form, nothing would happen. Hence why we need to handle the postback in update async. And what we'll do in this update async is that it will be super simple. And again, this is something that can be much more complicated, but this is just the very beginning. What we'll do here is that we will create a view model. We will then update the view model from the post data. So this try update model is pretty much the standard MVC thing. It uses the ASP.NET Core MVC model binder to bind the post data to the model. And then we can use the now updated view model to actually populate the content part. So we will need to do pretty much the same, just in reverse. So I will copy paste this thing here, and yeah, we will need the view model on the right hand side, and we'll need the part on the left hand side, because now we are updating the content part from the view model. Yep, and we actually it would be actually a bit better to use the edit async methods here. All of these methods have a synchronous and an asynchronous edition or version of them. We use the synchronous, of course, if your code is fully synchronous. If you are calling into async APIs, like we are doing an update async with the updater, or with this try update model async call, then of course do use the async versions. Use the appropriate one always. Yep, and now we have the update async method also done. But we also need a corresponding shape template still, like we do for the display template. So I will come here and add that one. So this will be personpart.edit.cshtml. And I will, again, cheat a bit so you don't have to watch everything. Again, I will need to specify the view model's namespace. Yep. And here we have the editor. The editor is pretty much standard, so what you expect from ASP.NET Core MVC template. We have field sets for all of these fields. We have one for the name, input. We have labels and input elements, as well as we can have hints. If you have a container here with the class hint, then it will be displayed, or it will be styled in the same way on the admin, a bit smaller, a bit grayer, probably a bit italic as well. Yeah, and we have birth date and handedness here in the same way. We will need to specify the namespace of handedness here too. So that's models, not view models, dot handedness. Yep, and what's the issue here? That's probably just a phantom error. And as you can see, we have our templates here. Now, let's start the application. We will go back to our person editor and we'll see what actually happened here, what actually changed, whether they have all the fields here. And if everything looks all right, we'll also edit this new content item. We will save it to the database and we will also check it out how it looks in the database. And it's here. All of the fields are properly displayed, so that's promising. Let's actually fill it up. So the name can be John Doe, as usually, of course. Birth date, we get a nice date editor, since it's an input field with the type date, so we'll automatically get a semantic date editor. So whatever, we can have some date here. Handedness, maybe right is a bit more popular or more frequent. And we can have a biography, like this is a biography. Well, not a very interesting biography, but nevertheless. And let's save it. Well, it seems that this was indeed saved. If we open the preview, we can also see it on the front end. Oh, it looks pretty nice. Biography, everything is displayed. Do note that the biography now is above our content parts display. And of course, we could change this with placement. But this is now up to you. You already know how to use placement. And if we go to the content list, we'll also see the same content item there. Yeah, person page. Now, that's pretty cool. Let's actually take a quick look in the database how this looks like. What I will use now is a little utility called DB Browser. This is a freeware utility that you can use to browse an SQLite database. It's super simple, super simple to use and very useful. So again, where we need to go is the folder of our web project. So I will just copy its path and open it in DB Browser. Yeah, let's go to that folder. And of course, the database is still under sites, under app data, sites, name of the tenant, and ESSQL.db. All right. And this is kind of our first look at the Orchard database. So let's take a good look here. What we see here are a lot of tables, but pretty much or almost all of these tables are of two kinds. One of these are called something index, and then there's the document table. So what gives? Well, let's take a look at the document table first. And what we see in this document table is, well, a lot of stuff, but these are actually documents. And if we scroll down, this is audit trail. We have something with person page here. So let's take a look at the details of it. And let's open it here in the right hand side. Yeah, this is a bit small, but still I hope it's more or less legible. And we can also format it nicely with this button here. Yeah, now it's better. So what is this document? What are these documents? These are our content items, serialized into JSON documents in this document table. Because remember that Orchard uses a document database approach in an SQL database by default. That's happening with ES|SQL. And what this means is that when you save a content item, a corresponding document, so pretty much a corresponding row, will be saved in the document table, which will contain a JSON document containing all the data of that content item. And we do have all the data of that content item here. So you see author. So those are the basic content item data. This is not coming from our part. This is provided by Orchard, including all the other metadata like this alphanumeric content item ID, or the content type, or when this operation happened. And if we scroll down, we also see the details of all the content parts and content fields. And under this person part section, we see that we have birth date, handedness, and a separate section for the biography, which only has a text. So you see all the things are here in this single JSON document. And as I said before, when talking about deployments and import-export recipes, this is the same thing that is also exported and imported. So this is a storage format, but it is also portable. So this is great because this is simple. The schema is dynamic. You don't have to create columns in a table and so forth. And also it's well performing because in a web application, in the overwhelming majority of cases, you are reading data from the database. For example, you are retrieving a single content item when you open a page, or you are listing content items. So in all of these cases, it's great to have all the data of that content item right there in this row, and no further questions. However, the issue is when you want to run queries on these content items. Like, I want to fetch all the right-handed people. And you can't really do that well here because this is JSON. You can't really query JSON. You could fetch all the person pages and iterate through them and filter out the right-handed people, of course, but that's not really efficient. That's fine if you have a couple of person pages, but if you have tens of millions of items, that won't scale. And that's why we have all these index tables. These index tables are tables that contain rows that have columns useful for filtering and other querying of these content items. For example, we have a content item index table here, and if you open it up, this is not a document table, so this is just a very, very standard SQL table with simple columns. And what you see here is that, for example, we have rows here with the column content type. If we scroll down, we'll also find our person page, and there is all the pages and all the blog posts. And we also have columns for the published flag. So if this content item is published, we will have a 1 here. Similarly for all of these timestamps. Now this index can be used to query on these fields, like I want to fetch all the person pages, or I want to fetch the person pages created in the last 5 days. You can write an SQL query, a standard SQL query, that queries this particular index table, and then you can join in the documents. So this way you kind of get the best of both worlds. You can, since we are talking about tabular data in this case, you can query, filter, order the tabular data in SQL as you would do normally, but you still get all the nice serialized documents with all the data in there. And if you don't want to query, you don't even need index tables. We haven't queried our person pages yet. We haven't created an index table for our content part yet. So this wasn't very necessary. This will be the topic of a future tutorial. But for now, that was about the basics of content part development. Our person page works. We can save data, so that's kind of a win already.